Hello everybody, welcome or welcome back to my channel. This is the AI Explained Like Your 5 series part 6, where today we'll be learning large language models or LLM. I hope you've liked the past five videos up until part 5. Today we'll be seeing part 6, where we'll understand what is an LLM, tokens, context window and so much more. What actually makes an LLM large, how it reads text and tokens, and why every conversation has a limit, explained with everyday analogies. You might have also felt it, ChatGPT or Claude, whatever you're using, right? After some time it gets limited and it says the limit is done, come back after so and so time, isn't it? So why does it happen? All that we'll see today. It's going to be interesting. And right now, till now I spoke about general things, something which is easy, fundamental. Right now we're slowly getting into the heart, soul of AI. There's so much more as well. But this complete series is completely beginner friendly, student friendly. Someone who has no essence of it will definitely get some essence by the end of the series. That's the main intention as well. So, large language model. What makes it large? So, a large language model, LLM, is a language model. The word prediction system from part 4. We learned in part 4, you can check about tokens now we spoke. Built at a massive scale with billions of adjustable settings trained on huge amounts of data. Huge amount of text. A small language model is like a phrase book. A few hundred handy phrases for specific situation. Small book is there which has certain words only for particular situations you can use that. But a large language model is like an entire library. It has read a staggering slice of human writing and kept billions of tiny adjustable settings tuned from all of it. Does all the words, all the situations can be dealt with the amount of content it has. That means that much content is already absorbed. It is worked on massive training data, trained the enormous slices of books, articles and websites far more than any person could read in a lifetime. Billions of parameters, the weights from part 3, we learned weights and biases. Here numbering in the billions, each one a tiny adjustable norm shaped during training. Broad general skills, having seen so much it can handle countless different tasks, not just one narrow skill. Large, but don't think that this is super AI. It's just a weak AI only. We have learned weak AI, all of that in the beginning videos. Check it out as well. Large isn't a marketing word here. It's a literal description of the training data and the number of internal settings involved. Don't get confused by anything. You didn't understand weight, you didn't understand bias. It's confusing. Just remember, large language model is nothing but, why are we calling it large? Is it a marketing gimmick? No. Just remember, it is being trained on billions of data texts. It is because the high amount of large training data and the number of internal settings involved. That's why we call it large. So that's all you have to remember. Don't over stress as a beginner. So what is an LLM? What it learns and the two modes it lives in. An LLM doesn't memorize facts like a filing cabinet. It learns the statistical patterns of a language. It's not going to memorize the billions of text, billions of words. No, what is it going to do? It is going to learn the statistical patterns of a language, its grammar, its style, common knowledge, well enough to generate a fitting response to almost anything. Okay. Now let's understand between training and inference for an LLM specifically. We have learned training inference before also in the previous video. Let's deep dive into LLM's context. So training, the model reads its enormous text collection over and over, adjusting its billions of weights until its predictions get consistently better. Basically, I'll tell you simply how you can understand it is. It's going to read so much data again and again. It's going to make a mistake, correct itself, make a mistake, learn, correct itself. That's how it's going to understand. It's adjusting its billions of weights until its predictions get consistently better. Done once by the company that builds it, expensive and slow. Training. Inference is you type a prompt and the model generates a reply token by token using everything it has already learned. No further learning happens here. Happens every time you chat with it, fast and repeatable. So training is when it is undergoing so much of training data, billions of data, correcting its weights, making it more towards realistic answer, making it the predictions more better. That is training. You're learning still and it's going to be time consuming, it's expensive. Inference is you've already learned it. Now you're going to apply the knowledge by using token by token, token by token. You're going to reply to the user back. That is happening at a very faster rate. We might understand the concept token by token, token by token. We might take more time to process that also, but there in the machine, it's happening very quickly. This is why an LLM can't remember something you told it in a completely separate older conversation unless a separate memory feature saves it first. So, yeah, sometimes it does save, but if you're going to chat in different folders or something far differently, you will not be able to remember something told in a completely separate older conversation. We must have used to it. You will not remember. Ask it, send the file again, or it will give very unrelated answer sometimes. All of it is because it's not able to remember things. Because it's not based on remembering. It's based on prediction. It's based on token by token prediction to whatever you ask to it. So let's go through some common LLMs. Several well-known AI assistants are underneath exactly this kind of large language model. ChatGPT, which is built by OpenAI, one of the most widely used chat-based LLM assistants, popular for writing, coding help, and general Q&A. Gemini, built by Google, Google's LLM family built into search, workspace apps, and the standalone Gemini app. Claude, built by Anthropic, an LLM assistant built with a strong emphasis on safety, helpfulness, and careful reasoning. Just one line introduction on what these are. We have already heard all of these, isn't it? Llama, which is built by Meta, an openly available LLM family that developers and researchers can download and build on directly. Different companies, different names, but underneath all four are the same core idea: a large language model predicting one token at a time. That is exactly till now whatever 3-4 pages we have learned, right? This is exactly what to remember. Large language model is something which is predicting based on predicting, not based on memory. How is it predicting? Because it is being trained and learned on large billions amount of text data, predicting one by one token at a time. That's exactly what we need to understand. Let's understand the Lego bricks of language. We have all played with Legos, right? So tokenization is the process of breaking text into smaller chunks called tokens. The actual units an LLM reads and predicts instead of the whole words. We get in sentence, paragraphs, all of that, but internally what is happening is we're not calling the tokens as words. I'll tell you why. And the actual units an LLM, and the LLM reads and predicts the unit which is tokens. It's reading or predicting based on tokens only, each token at a time, instead of whole words. The word unbelievable, see, this is a word, but when tokenized, unbelievable, it's breaking into tokens. So when you're saying unbelievable, when you take this is unbelievable, it's going to break it into part by part like this. Common short words often become a single token, like for example, all of these can be taken as one single token. Longer or rarer words get split into a few smaller pieces, a bit like Lego bricks, connecting to build something bigger. Understood? So why does this happen? Why doesn't AI read text exactly like humans? Like how we say unbelievable, no, but why is it breaking to unbelievable? Why is it breaking? You see whole words and instantly grasp meaning. A model sees a stream of token numbers with no built-in sense of letters or spelling. Everything it knows about language was learned purely from patterns during training. We, as soon as we see it, we can say unbelievable. We can just read it and say we know it. But a model doesn't see it as a word. It sees it as a series of tokens. Token and token and token, token by token, token by token. It does not have sense of these letters, words or anything. Whatever it knows, it has learned in the training period. It's breaking down the patterns, whatever it has learnt. It might have learnt words beginning with un in different contexts. It's joining it now. Suppose ask an LLM to count letters in a long word, and you can sometimes get it wrong because it isn't looking at individual letters the way a person would. It's working with tokens which don't always line up neatly with the word's individual letters. Might seem confusing, but just understand now that the LLM is not going to see word by word. It is not seeing letter by letter. It's seeing token by token. Okay, that much you should understand for now. Why token limits actually matter. Every model has a maximum number of tokens it can handle at once, covering everything you type in plus everything it writes back. This is important. Now you're getting understanding why all of these limits is happening. Every model, whatever we discussed about 4 5, whatever was there, every model has a maximum number of tokens it can handle at once, covering not only what you send, even what it replies back also. Imagine a whiteboard can only fit so much writing. Once every inch is covered, you physically cannot add another sentence without erasing something first, isn't it? A model's token limit works the same way. It's a hard ceiling on how much text can be on the board at once. Understood? Very easily by understood tokens, isn't it? So long documents need care. A huge document may need to be summarized or split into sections to fit inside the limit at all. Cost is often per token. Many AI tools charge based on how many tokens are processed. So token count has a real practical cost also. Long chats can hit the ceiling. Very relatable, isn't it? A conversation that runs long enough can bump right up against the same fixed limit. One important detail, tokens aren't quite the same as words. On average, one token is 3/4 of an English word. Now, again, English words can vary in size. They're just saying an average is 3/4 of an English word is one token. So, limits are usually a bit tighter than the raw word count might suggest. Suppose the word count suggests 5,000 words. It's not literally meaning that the token is 5,000 tokens. Okay. It's going to be much more because one word 3/4 token. So for 2000 words, 2000 into 3/4, that many tokens. So yeah, I hope you can make understanding of that. The context window. Now coming to section 3, the context window. Everything the model can currently see. In simple words, if you can see. Context is all the text currently visible to the model as it generates its next token. The conversation so far, any documents shared, and its instructions. All of this. Context is simple English. What is the context when we speak? When I say, what is the situation you're trying to understand? Correct. Here, the situation can be the file which I have shared, the text I have previously sent, instructions which I have given to it in the same chat. That context. So, what is the context window? The context window is simply the maximum size of that visible text measured in tokens that the model can hold and consider at one time. So, what is it? Maximum size of visible text measured in tokens. Okay, it's measured in tokens which that a model can hold and understand at that particular time. Which is the model working at a desk of a fixed size. Only what's physically here on the desk right now can influence its next move. Anything left in a drawer or never placed on the desk at all simply isn't part of the decision, no matter how relevant it might be. Did you understand? Imagine this machine model is there, it's working in a desk. So what they're trying to say is whatever objects are there on the desk, it can only work with that at that particular moment. Something in the drawer, something in the shelf, even however important these two might be there, it's not going to get influenced by that. At that particular time, how much it can hold, how much context it can hold, how much information it can hold, how much file it can hold at that particular time, that much only is known as context window. It includes more than just chat. Context isn't only your messages, it also includes any uploaded documents, earlier replies, and hidden system instructions guiding the model's behavior. Bigger windows, bigger desks. Newer models often advertise larger context windows, effectively a bigger desk, letting them consider much more text at once. So it can remember much more, it can contain much more context to give better replies. Understanding? So why long conversations run into trouble, this we have also understood previously. The desk from the last page doesn't magically grow mid-conversation. Once it's full, something has to give. Correct? As a chat grows longer, more and more of the whiteboard fills up with the earlier messages. Once it's completely full, the earliest notes get erased to make room for new ones. So readers from very early in the long conversation can quietly fall out of view, even though the conversation still feels continuous to you. You might remember the context, but the language, but the model, what is it going to do is, once the context window is filled, now you want to add more of it. Context window is once the chat is filled and you have to add more information, the earlier messages will start to fade away. It might appear like it's in a chat, but it's in its context, it's going to erase away. So early details fade. A name or preference mentioned right at the start of a very long chat may no longer be on the desk later on. Responses can drift. Without those early details in view, later answers may lose some of the original thread of consistency. Restarting things helps. Repeating a key day later in a conversation puts it back on the desk fresh in the model's view again. It isn't the model being careless, it's simply a fixed size window doing exactly what a fixed size window does. Isn't it? Hope you understood. Now, context is first memory. This is again important. These two words get used loosely, but they mean genuinely different things. We always almost thought it same only, right? Context. What's currently loaded into this one conversation's window? It's temporary. Once content falls outside the window, it's gone unless repeated. Resets completely in a brand new conversation. Excuse me. What did I say? What's currently loaded in this one conversation's window? In this one context, in this one window, what all you're telling, that much. It's temporary. Once content falls outside the window, it's gone unless repeated. That's what, when new things are added, old things fade away. That's what, unless you tell it mid chat. Memory, a separate optional feature some AI products add. Specific facts or preferences saved on purpose so they can be recalled in future sessions too. Can persist across many separate conversations. This is a separate feature as it's saying. Okay, your purpose are on the memory, so all of your preferences are already saved separately as a feature. This is different from the context window what we were speaking. So simply way to remember is the context is what's on the desk right now. Memory is a notebook the model is deliberately allowed to check back on later. Understood? Why this distinction is useful: if an assistant forgets something from earlier in one long chat, that's a context window limit. If it forgets something from a completely different older conversation, that's about whether a memory feature was switched on at all. Did you understand? Very important. It's very nicely explained. That this desk whiteboard explanation understood, right? This is the context right now. So when we add new information, the older contents will fade away to fit in the new information. That is simple way to tell you. I say, I'm not an expert at all. I'm also a student. I'm also a beginner. I'm just trying to make things simpler. But at any point of time you feel my explanation is wrong or it's misleading, please let me know. I'll always be ready to accept it. So memory is a separate feature or as by its own. Where when it's turned on, not just in that one chat, not that just in that window of conversation, in any chat, in any conversation, you can use those facts which have been saved in the memory. Okay, that's what I've understood. One quick revision before we end it. Large language model is a language model trained at massive scale with billions of weights, parameters or weights, the billions of tiny adjustable settings shaped during training. Training, the one-time process of learning from huge text collection. Inference, generating a reply using what was already learned. Token, a small chunk of text that the actual unit and LLM reads. Tokenization, breaking text into tokens before the model reads it. Token limit, the maximum tokens a model can process at once. Context, all the text currently visible to the model right now. Context window, the maximum size of the visible text in tokens. Memory, facts reliability saved across separate conversations. So with that, we come to the end of part 6. It was a different topic from the usual part 5 what we have seen. So I hope you have liked it. Thank you so much for watching. See you in the next one. Until then, bye bye.